In this video, I will show you another example of diode clipper circuit. This will be example number 4. Sketch the output waveform of the following clipper circuit with given input. See, this is our given clipper circuit. In this clipper circuit, we are applying this rectangular waveform and we have to draw the output waveform across this terminal to this terminal. We have to consider this only diode as silicon diode. Silicon diode, that means when the diode will be in forward bias, we will replace it with its constant voltage drop model or 0.7 volt source. And when the diode will be in reverse bias, we will replace it with open circuit. Now let me proceed with the circuit solution. See, this is the only bias voltage here, the bias voltage V1. Its positive terminal is connected with the N side of the diode and the negative terminal is connected with the P side of the diode. As the positive terminal is connected with the N side and negative terminal is connected with the P side, I can say that the voltage source V1 is trying to put the diode D in reverse bias. Now consider the effect of input voltage. Consider the 0 to T/2 interval. In that case, the input voltage has a magnitude of plus 15. Vi is equal to plus 15. That means this terminal will be at higher potential and this terminal will be at lower potential. Okay, you will see the positive terminal of the input voltage during this interval is connected with the N side and the negative terminal is connected at the P side. That means the bias voltage V1 and the input voltage Vi put the diode D in reverse bias. So during this time interval, the diode D is in reverse bias by the bias voltage V1 and the input voltage Vi. In that case, I can replace the diode D with an open circuit. If I replace the diode D with an open circuit, I will get a circuit like this. As this portion of the circuit is open, therefore the current flow in the circuit I is equal to 0. The current will flow in this direction because this terminal is at higher potential and this terminal is at lower potential. Okay, now see, as the current through this path I is equal to 0, our output voltage VO should be equal to I into RL. We can get that by applying Ohm's law here. As I is equal to 0, therefore I will get 0 into 10 kilo ohm, which will give us a value of 0 volt. That means during the 0 to T/2 time interval, our output voltage VO will be equal to 0 volt. Now consider the T/2 to T time interval. During this time interval, you will see the input voltage will have a magnitude of -5. That means this terminal will be negative and this terminal will be positive and the magnitude will be 5 volt. Okay, now see, the bias voltage is trying to put the diode D in reverse bias and the positive terminal of the input voltage is connected with the P side of the diode and the negative terminal of the input voltage is connected with the N side of the diode. That means the bias voltage V1 is trying to drive the diode in reverse bias, but the input voltage Vi is trying to drive the diode in forward bias. As the input voltage has higher magnitude than the bias voltage, our input voltage Vi will put the diode D in forward bias. Therefore, I will replace the diode D with a voltage source of 0.7 volt. After replacing the diode D with a 0.7 volt source, you will see I will have a circuit like this. In this circuit, we are taking the output across load resistor RL with this terminal positive and this terminal negative. Now see, if I apply Kirchhoff's voltage law in this loop, I will apply KVL in the loop. I will get the output voltage. From this point to this point, I will see this input voltage. It's positive terminal first, negative terminal later. Therefore, its voltage will be -5. From this point to this point, I will see this 2 volt source. Its negative terminal first, positive terminal later. So its voltage will be +2 volt. From this point to this point, I will see the diode equivalent circuit of 0.7 volt source. Its negative terminal first, positive terminal later. Therefore, its voltage will also be positive, 0.7. After that, I will see this 10 kilo ohm resistor. As I am taking the output across this terminal to this terminal, I will see the positive terminal first and negative terminal later. Therefore, it will be -VO, which will be equal to 0. Now see, here I will get -2.3 minus VO equal to 0, from which I can write down our output voltage VO will be equal to -2.3 volt. That means between T/2 to T. Within this time interval, our output voltage will be equal to -2.3. For example, this is -2.3, and I will get a pulse like this because I am applying a rectangular waveform. In the output, I will get the same type of waveform. Okay, and this will have a magnitude of -2.3 volt. And this is the complete output waveform in case of this circuit. That's it. Thank you.